All right, sometimes the hardest problem with doing a proof is just starting the proof, knowing how to draw the picture, knowing what information is given and what I need. So I'm going to go ahead and first draw my picture so that I can get an accurate idea of this situation. So I'm going to label my vertices A, B, and C. Okay, I was given that AB is equal to AC. So I'm going to go ahead and mark those on my diagram. And I also know that because this is an isosceles triangle with these two sides congruent, that the base angles at C and at B are congruent. So I know that those angles are congruent. All right, so now trying to figure out the rest of the problem says, it says the medians drawn from vertices B and C. All right, so just to recall, a median goes from the vertex to the midpoint of the opposite side. So if I go ahead and I mark the midpoint there, I'm going to mark the midpoint by marking these segments, and I'm going to draw my median. And then I'm going to do the same, and I can go ahead and mark these congruent because I know that if side AC and AB are congruent, that the midpoint would divide both those segments into congruent pieces. Okay, so I'm going to go ahead and draw that right there. Now, hopefully this is looking kind of familiar. I'm hoping this looks like something that we've done before. I'm going to go ahead and mark those midpoints, D and E. All right, and then I'm going to come over here off to the side and I'm going to draw those two triangles inside the big triangle that I've drawn. So that'll help us see what's going on a little bit better. So I have D, C, B. And I have DC double marked. I have this angle right here with a single mark. All right, I'm going to go ahead and draw that other triangle there that we have. So let me draw that off to the side here. Of course, we all know Mrs. Carpenter's artistic abilities are fantastic. So we might have to use our imagination a little bit. All right, we have this side EB marked the same as CD. And we also know this angle. So my goal in this is to try and prove that the medians have the same length. Well, our medians are the pink lines. So we're trying to prove that CE is congruent to BD. That's what we're trying to prove. All right, so now looking at this, I notice that I have a side and an angle. So I'm going to be able to either use side angle side or side angle angle, also known as angle angle side. So the question is, can I get the other angle or can I get another side? Well, isn't CB the same side in this triangle that it is in this triangle? So now, which one of these would I have? All right, I would have side angle side. And then after I prove that these two triangles are congruent, so in my proof, I need to write all of this out. I need to explain all of this, but I'm going to go ahead and just start our proof with saying that the triangle CDB is congruent to triangle BEC. And we can say that by side angle side. So after that step, I'm now able to conclude, based on the ordering here, I need CE to be congruent to BD. Well, if you notice, here's B and D in the first triangle, and here's E and C in the second triangle. Since they have the same ordering and they're in the same order on each of the triangles, we can conclude that CE is indeed congruent to BD by CPCTC. So again, this proof would entail you would have to write it up and you'd have to go ahead and state that you have the three pieces of information. So you'd have to have CD congruent to, let's mark those. You'd have to have CD congruent to BE at some point. You'd have to have angle C is congruent to angle B. And you'd have to say that CB and BC by reflexive property. Then we can go ahead and finish the proof with this.